инициативы, поэтому тот формат проведения мероприятий, который есть, вот мы его опробуем впервые и будем надеяться, что у нас сегодня все получится.
Welcome, everyone. We know that this year has been challenging, and now we have changed the format, and this year we'll be broadcasting our events this way. We understand that we want to meet each other in person to discuss the topics in terms of mining and education together in person, but now we have to do it remotely. So we understand that an important minus week has started, and I'd like to highlight the issues we had last year. Unfortunately, many renowned colleagues were gone, and 3 members of the organizing committee of the minus week, the ones who were determining the scientific agenda of the symposium, are gone. Vladimir Shkuratnik, professor and renowned scientist of Russia, and renowned builder, Melnikov and Skachitskin Award laureate, and renowned professor of NASMISIS, Leonid Weisberg, scientific head of Mechan Obertechnica, 3 times winner of the award of the government of the Russian Federation in science and technology, renowned builder of Russia, academician of the Russian Academy of Sciences, renowned professor of NASMISIS, and renowned scientist of Russia, laureate of awards of the Russian government, member, correspondent of the Russian Academy of Sciences, and director of the Moscow Mining Institute for more than 20 years, Lev Puchkov. All of them were gone within the last month, and 2 of them passed off for the disease, which has put us all on hold. So let us have a minute of silence to remember them. Thank you. So let me welcome you again. I'd like to thank those who are here with us in person. I'd like to thank those who are online with us, those who are watching our broadcast or going to watch it later. Now we are in the innovations point in the Moscow Mining University, our college. And in the past here we had the latest equipment provided by the machine building and mining companies. And now this new environment is full of latest labs, and it shows the college as of today, and it will be a venue for many events. And now I'd like to invite to the stage head of coal industry of the Russian Federation, Sergei Macharnikov. He'll come here to the stage with some welcoming remarks.
Уважаемые коллеги, я безмерно...
Colleagues, I'm really happy to be here. And, well, we know that the past year was quite challenging, and this year is beginning in the same fashion. Nevertheless, we are optimistic about our future, and the minus week is a leading mining event, bringing together scientists, those who deal with the latest technologies. We are really glad to be here, and we, on behalf of the Ministry of Energy, would like to convey to you the welcoming remarks. to the members and organizers of the 29th International Symposium, the Miners Week 2021. Ladies and gentlemen, colleagues, friends, on behalf of the Ministry of Energy of the Russian Federation and on my personal behalf, let me welcome you to the 29th International Symposium, the Miners Week 2021, which is recently held by the Mining College of Nast-Misses. Russia today is one of the leading coal countries, and the mining of coal has always been important to Russia, and we have been always proud of it. And the miners' profession has been always in great esteem. And the production potential of the industry is developing on the latest technologies and high-performance equipment and latest technologies and approaches to labor organization and safety. It's important to make our work even more effective and efficient. We need to expand our export potential. It's noteworthy that today it's important to introduce in coal mining companies some innovative solutions for production, beneficiation, and deep processing of coal. And this is really important for scientists and designers and engineers in the field. And this is a lot of experience for the students to obtain. The Miners Week is one of the leading Russian platforms bringing together businessmen, scientists, and government officials who discuss the future of mining and technology of mining. And next year it will be the 30th anniversary of this event. We bring together universities, mining companies, and service organizations. And this symposium has brought together renowned experts from various countries, and very promising topics have been discussed. I'd like to congratulate all of you on the active work you are beginning now in this forum. I'm confident that this event is going to be really well organized, and the environment will be full of interest, and I wish you a successful effort in this endeavor. Anton Tiginovsky, Deputy Minister of Energy of the Russian Federation. Thank you. Thank you, Sergey. Thank you, Anatoly. Anatoly is a member of all our events. Now the floor goes to the Academician of the Russian Academy of Sciences, President of the Academy of Mining Sciences, Valery Malyshev. Colleagues, you know, this is an unusual event. I cannot see those who are not present in the room, naturally. Let me welcome our colleagues from Russia and abroad. And I believe that we have miners from Europe, Asia, and Australia with us today. Let me welcome all of you on the behalf of the Academy of Mining Sciences. I'd like to say that jointly with our colleagues in Kazan, we are developing the Eurasian Mining Academy, and now we are building the World Mining Academy, as we announced the committee of the World Mining Congress. Well, talking about the current developments, we understand that now time is unusual to all of us. And I can tell you that the mining industry in Russia has gone through these difficult times in a very good shape. In some of the factories and companies, we had outbreaks, but overall, the companies are coping. They have invested a lot of funds into prophylaxis, and the mining industry in Russia is further developing. We are introducing new mining plans, new quarries, and now we are exploring new areas. And the Far East is developing following the presidential decision. The Tuvin area, Buryatia, Yakutia, the Far East regions, we are building new quarries, new pits, and new plants. And this gives us confidence. And I believe that today we should be focused on new solutions in terms of science and in terms of staff training. I'd like to tell you that changes are happening. And last year, we started robotized equipment testing. So we have 2 BELAS trucks without operators. In the SUAC mines, we have unmanned technologies testing. We use remote control for low-risk nickel, for Sagra and others. And now we are standing here at Mrs. and we have rector and vice rector with us, and we are jointly establishing a new mining profession. The mining engineer who should be able to remotely control the machines. And in this regard, it's really important to properly select the staff. Jointly with Mrs. and the Oil Institute and the Academic Center for Navigation, we are now arranging a set of contests looking for gifted children. We also have teleconferences featuring our scientists, academicians, politicians, and industrialists. And more than 50 universities are participating in this. And so there are participants from Uzbekistan, Kazakhstan, Kyrgyz, and Belarus with us. And this will be further developing. And the pinnacle of this is the publication of our new magazine, Mining Junior magazine. So this is for the young, for the school children and students, for the master students and other young professionals. This helps us find and invite really gifted HR. So this meeting, the plenary, we'll be talking about the future of mining. And I know that this will be well covered by our magazines. And our mining industry magazine has been recognized by Scopus. Congratulations, and I wish you all the best in our Miners Week. First Vice Rector of the National University of Science and Technology, Sergei Salihov.
Уважаемые коллеги,
Colleagues, it's my pleasure to welcome you to the 29th Miners Week. We've been holding it since 1992, and I believe that this is one of the longest standing, one of the oldest events in the mining industry. And the Miners Week has been evolving. And now we are testing new formats, and as Yuri has mentioned, now we are also discovering new topics. So we understand that this week has some specific features to it. Primarily, this is the remote format. But I believe that we all feel our colleagues in all the parts of the world. This includes our partners from Australia, Chile. I can but mention our traditional partners from the Freiburg Mining Academy. And I have from them the title of the distinguished miner. And so we are all the big mining family. And we come together for the Miners Week, as usual. The second change this year, the organizing committee and the program committee this year decided to focus on digitalization of the mining industry, on the development of digital technology in mining. We are confident that the future lies with the mining industry. And the digital technology, which is introduced everywhere in the quarries and in the open pits, this technology will be important for the mining industry for a long time. And the 29th week, Miners Week, will be a tribal, and hopefully we'll further discuss it in person in the 30th week. I'd like to welcome our colleague Marek Zala from the Krakow Mining Academy, who will be also unveiling this symposium. And as Alexander mentioned, we should remember those who have been with us all this time. And, you know, on my way here, I thought about the late calls to Leonid Weisberg. And I said, is it late? And he said, well, Sergei, friendship is round the clock. Well, listening to their wise advice and their ideas and the ideas related to digitalization of mining, well, this is really important. And we should keep all this in mind and move it further. I'd like to say that we are glad to welcome everyone, and we feel everyone who are with us here and listening to us remotely. So this is a special week. And I want all of us to start thinking about the agenda of the 30th week, Miners Week, which will be our anniversary week. And I believe that it can be focused on digitalization, the new mining technology. And this can be a real world-class symposium. I hope that we'll be able to come together in person next year. I wish all of us great ideas, a lot of fruitful work, new and interesting ideas and stories throughout our Miners Week. I wish you all success. Thank you. Thank you, colleagues. So now we'll start inviting our speakers. And now the floor goes to the first speaker, unveiling our plenary, the Dean of the Mining College of the Krakow Mining and Metallurgy Academy, Chairman of the World Mining Congress, Professor Marek Zala.
Hello, everyone. Thank you very much for your nice and kind words during the welcome. Now I would like to try to show you my presentation. Okay, it should be okay, and the full screen should be visible. Ladies and gentlemen, thank you once again for such a nice meeting here, for such a nice welcome here during the Russian Miners Week. I congratulate you the 29th birthday of the Miners Week. We as the World Mining Congress, we started in 1958. That was the first Congress in Warsaw. Next one we're going to have in 23 in Brisbane, Australia. There will be some chance to speak about it later. Okay, so we generally, if I try to summarize the future of mining and metals industry, so it goes out to the 7 trends. The first trend is a transition to low carbon economy. So demands for the most of minerals is projected to be high in order to achieve the energy transition. Countries must, or at least they should, to decarbonize their energy systems by the middle of this century. Given that low emission energy and transportation systems are more mineral intensive than the fossil fuel based counterparts. So the transition also should be considered as a great opportunity for mining sector. At the same time, of course, the mining sector should reduce their own emission. Access to the resources. Companies will need to venture into frontier mining areas. As world-class mineral resources in low-risk areas become exhausted, mining companies must either master new technologies for extraction and processing, or venture into frontier areas where extraction has not previously been economical. New ways to finance mining. As mining companies try to risk, novel financing and production models will become more common. Alternative financing solutions were developed, such as royalty or metal stream agreements, to reduce the burden of the mining companies. A social contract. You can also look at this picture here. This is the point where the arrow, this is values today. We have socio-economical culture. We have environmental and biodiversity. In the future, in the near future, right here, we should go in each possible axis forward, move forward. We have to be better in almost every aspect of mining. Also a social contract. Obtaining the license to operate from local communities has been a challenge for the mining industry all over the world in recent years. Many proposed projects have been rejected. Operations have been disrupted by the protests. Big data and mining. This is also a very important point. So data transparency to aid mining industry relations with the stakeholders. Collecting and processing the massive range of the data, amounts of the data will be essential for mining companies as they digitalize and automate their operations. The geopolitics of the mining is also very important. Mining companies must navigate rising geopolitical risk and economic protectionism. A growing popular resistance to globalization and free trade is altering politics and differently affecting the mining and metals sector. Modern mining workforces. Maintaining an open dialogue will be a key as mining companies try to revamp their employees base. That's what was talking by academician Malyshev just seconds before. The sector will increasingly compete with the IT sector to attract top talent from the universities in order to drive its digitalization and automation process. But do not worry, mining, instead of different protests, will not disappear. We need to know the fact that primary extraction will continue with the volumes, but unlikely to grow in line. That will not grow in line with GDP growth. However, we have to pressure to realize scale effect and cost efficiency. This is the close future. So altogether, demands for cost effectiveness, demand for environmentally and socially responsible actions. That will be a new challenge for us. Of course, technology will be the key. It will become increasingly important to better understand the supply chains and consumer preferences. Facts. So finally, the European Union performs an action to secure the access of critical raw materials. European Union says goodbye to the coal mining, both underground coal mining, especially in Poland. We are the last man standing actually in underground coal mining, and also try to reduce the amount of open pit mining of brown coal or lignite because of the European Green Deal. But Finally, it's a very good thing that the EU strategy recognizes the importance of critical raw materials. It took them a lot of time, but finally we did it in clean technologies, because they know that during the prognosis in the 2030, we will have 8.5 billion people all over the world. So during the next decades, the not so ready mining industry will have to overcome the challenge of providing the critical metals and elements, situation that haven't been found yet for an extra billion people. This is a real challenge. This is how the European deals. They said that 29 or 35, that will be carbon neutral. I don't quite believe that, especially maybe for Europe, that's a plan, that's an assumption. But look, what is the answer from China? This slide I borrow from Professor Zhu Huarong, the Director General for China National Coal Association, and she showed us the person from the World Mining Congress just last December. So by 2025, that would be the amount of billion tons of coal that China will need. 4.1 their own, plus 200, 300 million tons of export. The peak carbon dioxide emission would be in China by 2030. These are the years that the EU should be carbon neutral. So can it be possible to agree China and Europe? I don't think so. By 2060, China will achieve carbon neutralization. That's about 40 years from now, not 10, not 15, 40 years from now. And these are the facts. So what do we need? This is a very important, and I underline the word we, the population of miners all over the world. We need to reach a consensus, taking into account the Paris Agreement, maybe with different speed, because European speed and China speed is absolutely different speed. However, we must improve the efficiency of mining, social, environmental impact. So this is like a trio which goes everywhere. Bottom of the seas, oceans, asteroids go down to stay on the top. And of course, highly efficient technologies. That's what we must improve. I will not tell you about the classical mining that we know perfectly. I will going to tell you a little bit about the different kinds of mining, the new kinds of mining. Then, with the real pleasure, I was just hearing what academician Małyszew said about the junior academy for mining. This is what I'm calling geo-education. And that would be about the traditional mining and application of the modern methods there in the classical mining. So deep sea, not started yet. Not yet anyone digs in the sea. However, we have 16 international mining companies ready to go. The Belgian group says they'll start in 23. Hopefully they do. Another effect of global warming is melting Africa's Arctic ice. So the possibility for US, Russia, Canada, Norway, and Denmark, the countries which have the demands concerning Arctic, to deep seabed mining. However, be careful. The depths of our oceans hide a unique living world that we barely understood. But these mysteries are under threat from a controversial new industry, deep sea mining. I tried to even have the intonation of the voice by the guys from Greenpeace. We didn't even start to do any deep sea mining, but still already they are against that kind of mining. That will be not easy. That will be not easy, but we definitely will have to do it. Urban city mining. This is a very important kind of mining. This is like a global world production, 50 million tons of e-waste. E-waste, it is growing. The more cellular phones, computers, TVs, and IT stuff we use, the more urban city mining is possible. Of course, this is classical, like landfill mining, tailing, slugs, waste disposal. But also, these are actions of collecting, for example, old cellular phones from the cities, from the populations. Asia is the highest producer. Europe is the second highest producer of e-waste, throwing away about more than 20 million tons electronic equipment and batteries. If we consider how much copper, so this is more than 300,000 tons of copper, 31 ton goals. More than 300 tons of copper, this is 1/2 of the Polish CU production. That's what Europe throws away. These are facts really to think about. Another kind is biomining. So to extract the metals in economic interest from rock ores and mine waste. To extract or just to clean up sites that have been polluted with, let's say, polluted with metals, that we can extract this to clean the cities, the places, and to extract that metal. What kind of metal? Quite interesting metals: copper, uranium, nickel, and gold. These are the interests of biomining. With the bioleaching also and biooxidation, I would not go into this subject. These are probably well known. Let's have a look at the numbers concerning biomining. All this is increasingly used to mine deposits with low percentage of copper. And we have about that number of copper is extracted using bioleaching. Biomining, gold industry, 5% of golds. So these numbers are really growing up, and the microbial miners maybe would be our favorite for the next decades and next generations. So this is what is happening. This is what is the future. Is it so far away future? I don't think so. Look at the NASA Artemis program. This is going on now. They want to have the American astronauts on the moon by 2024. So they're back after half of the century, more than half of a century. They are going to send people to the moon again. Future exploration, including Mars. Why for? Space mining will probably start on the moon, but then this is a straight road to the Mars. If you remember, last December, China mission returned moon samples to the Earth. First time since 1976, there was a Soviet lunar missions brought the samples to the Earth. So Chinese are the third nations who has these samples of moon rocks. Almost 2 kilograms of lunar samples, extremely interesting for scientists because they are less than 2 billion years old. This was the first step of China to the moon. What would be the next steps? The models of space station will be transported to the moon very soon, according to the Chinese plan. And Beijing also had ambitious space lunar station 25 years, maybe even earlier. Another point, again from December 2020, just like last month. Last month, the Japanese spacecraft Hayabusa 2 get back to the Earth, bringing us the asteroid Ryugu dust. This asteroid Ryugu dust will be distributed to 6 teams of scientists to compare their investigations. So here is the picture of this Ryugu asteroid, and this is the sampler with the Ryugu dust. This is also extremely interesting, and this is a future of mining. This is actually what is going to happen very, very soon, or is just happening. In traditional mining, we are also improving. This, for example, is the model of the underground salt mine. This is built from more than 40 million finite element method elements. And this is, we need to construct this model to answer the questions if we can excavate salt in the caverns for another 30 years in this mine. So we have to be back in time to simulate the 40 years of past excavation to be able to simulate the 40 years of future excavation to build up such a great and geomechanical models. This is what we are doing for the open pit mining. This is the CAD files. This is the geological sections. From these sections, we produce such a numerical models. In such numerical models, we investigate the possibility of slope stability lost. We can see it here on the cross section, and in the upper part also in the cross section. We can see the possibility of lost. With the development of excavation, another possible slide prognosis and slide forecast may be formulated. This is what we are doing classically in Poland. This is the another picture of quite huge Polish open pit mine, which I'm going to show you. This is the inner dump. All this green, dark green color, this is the inner dump of that mine. This is before. This is after. After what? After that stuff happened. This is probably the biggest landslide, I would say, all over the world in open pit mines. This is the surface of the mine. This is the volume of the landslide colluvium. So we have 500 million of the cubic meter, which goes to over 1 billion tons of mass, which were removed. That took place in this year. So we have to perform the numerical modeling to calibrate it and define how does it happen. So it started from here. Maybe it would be better to show you like here. It started to here. That was the source. That was the movement like that. After that kind of movement, this was another part of movement. It's like a domino. Then this part goes through, and finally another one. So starting from here up to here, this part and this part will move. That lasts for 2 days. No fatalities, thank God, but the mass is huge. Now getting back to the geo-education, that's what we need. Mining does not have a positive media image, not trendy, certainly I would say even not sexy. So how can we lead to change, to revolutionize mining and make the people see for that what is essential to the humankind survival? We need the concept of geo-education, and starting as soon as in the kindergarten. In the kindergarten, and then to the primary school, and so on, to seek for the future mining supporters and future miners. The sooner we understand it, the better we can prepare it. We have all over the world protests against mining. This is the famous protest from Chile. This is like agro si mina no, means agricultural yes, no mining. We don't want to go with the mining. Miners, go somewhere else, not in my garden. This is the example in Mongolia. Someone would say, totally mining country. Yes, but with the protests also. That's why there is such a need for a geo-education. Ladies and gentlemen, this is a very difficult to forecast the future of mining. But we can say one thing for sure, there is no future without the mining. The last part of my presentation, that would be telling you a few words about the next World Mining Congress, which awaits us in June 2023 in Brisbane, Australia. So this is the picture of the, excuse me, something, okay. This is the picture of and the name of the Congress, and I would like to emphasize you with the name Resourcing Tomorrow. Creating value for society. We must get people together that these two words, mining and society, can stand very close to each other through the technology, connection, and transformation. That's what we are planning to do. Australia, I should not describe you the beauty of the country. Australia, city, Brisbane Convention, World's Best in 2016. Our sessions which give me special satisfactions because these are very important sessions and the new sessions for Mining Congress. With the old one, like environmental sustainability, that one we owe perfectly. New mining frontiers. This is the space mining, this is the space exploration. Artificial intelligence in mining. Of course, autonomous system, Alexander was speaking about this. Social performance in science, education, like geoeducation, and of course, critical minerals. We cannot avoid decarbonization. Yes, I'm just heading to the finishing my story. This is the core of the Australia. These are all sessions names, as you can see here. Digital transformation, zero emissions, circular economy, and at the end with the people, person, who are in the middle of all that. The important data, you can read it from the presentation, and accompanying events. This is the Australia-China Mining Summit, EU meets Australia, and the proposition for Russia. Maybe we can organize Russia meets Australia events during that summit. Why not? Just think about it. This is the last slide. This is the chairman of the Australian committee. And this is me. This is me in the parade Polish uniform with the dean's chain, with the traditional sword, shako, and the mask. The sign of the COVID and pandemic. Thank you very much for your attention. I'd like you to play the movie for concerning Brisbane now. Thank you very much.
Огромное спасибо. Благодарим.
Thank you. Thank you very much indeed, Marek. Thank you. That's a very good proposal. We have Valery Zakharov with us, who is head of the National Committee of the World Mining Congress. So maybe this proposal on the Russia meets Australia events is a very good one. So we should consider this. Thank you. Thank you very much. And now the floor goes to Vladimir Trapezin, who is head of technological breakthrough program in the Norilsk Nickel company. Hello.
Секундочку. Здравствуйте, уважаемые коллеги. Норильский никель.
Hello, ladies and gentlemen. We know that Norilsk Nickel is a global leader in the production of palladium and high-grade nickel. We produce copper and other metals. Our production facilities are in several countries globally. We have our production facilities, R&D facilities, a unique transportation, livestock, and we also have the important areas in the polar region. In 2015, Nornickel started implementing the technological breakthrough program. The program is designed to make the production processes new so that they use multi-various planning and use automated operational control. This includes the integrated control of production, technological retooling, better productivity and safety by using new production processes, latest information systems, informational support, and automation. This slide shows the key stages planned and our current progress. The changes encompassed all the departments of the company in the operations, and we go all the way from production of ore to the production of metals. This comprehensive approach included about 40 initiatives and the implementation of about 20 information systems. All of this needs a deep dive from the management, from business, from production, from IT, and the program and project management system is designed for continuous work. And irrespective of the changes internally and externally, including the COVID challenge, we still pursued and we are moving in line with the deadlines we envisaged. Before we launched the program, we looked at the experience of the Russian and international companies and other industries, and we had a lot of consultations with consulting and technological companies. Many of them had experience and practice in implementing products to introduce solutions for higher production efficiency, but we didn't see any ready solution which would let us bring the production capacity to a brand new level. And this was our task. That's why we decided to develop our own strategy. We started by analyzing the existing processes. We understood that we couldn't build add-ons to the old processes for the long-lasting effects. We analyzed the effectiveness of the production activities. We selected KPIs for all the processes. We determined the success criteria for all the processes. We audited all the solutions, including the industrial automation area. We brought together the expectations of the business and discuss the achievability and put together the milestones for business for the next 5 years. And for this, we developed the portfolio of projects, which was united into a program. The first stage took 5 years, and as a result, we obtained 44 information systems used by more than 3,000 experts and managers in business and in production of most of the facilities of the group. All the projects of the first stage were completed, and they included primarily baseline automation. All the underground queries have positioning and communication systems, and almost unlimited data transfer capacity is available for underground and above the ground exchange. We brought together the manuals and technological maps for the crucial equipment for managing the facilities and equipment following one logic. We introduced mining and geological information systems to bring together a unified database, and we also developed a 3D model of the underground ore bodies, and now we have 100% of ore bodies digitalized, and all the discovered deposits, and we have the plans of mining, and we can build models on them to see whether they are feasible. We have an imitation model for the query, and it works very quickly, 10 minutes for the year model. And we can control all the processes online from the Koilsk Operations Center. The data comes from all the departments, and this lets us build the metal balance for every stage of processing, and we can keep track of the flows and the actual amount of the products produced. Our automated control, management and safety system was introduced with 12 facilities. More than 5,000 staff are now using this system, and one of the effects expected is the reduction of probability of accidents due to the continuous monitoring of risks and the development of methods to prevent negative events. Now the system is used by all the levels of management to identify hazards, to investigate into accidents, to control the current work, to do production control, and also for supervision and for the permit processes. In the polar region, we understand that heat energy is crucial. At all the stages, the production facilities consume a lot of electric power, and the metal companies use a lot of natural gas, air, and technological oxygen. And the costs here are billions of rubles. To make our production effective, we need to take measures to improve the use of utilities and energy sources. The automated system for energy resources reports brings together these reports and keeps track of the usage of all the types of energy resources for more than 20 large companies in Taimyr. We have a storage for technological data, and there we also accumulate telemetric equipment, which comes from rotating equipment. And there we have information like the rate of engines and so on. And we have more than 100,000 parameters there in the storage. I'd like to talk about one of the largest projects, which became the program of dispatch, underground dispatch service. It works in 7 quarries of Nornickel, and we believe that it is unprecedented in Russia. We have underground infrastructure, which supports management and planning for mining. So we support the whole program in the whole query processes, and make our data more trustworthy. We have a very strong data transfer system from the surface to the underground and backwards. We cover almost 100% of the mines with our network. We use network equipment for wireless equipment, and this is designed in Russia. All the information comes from the mining equipment, and it is transferred online to the operator, who is in the operations center on the surface. The dispatcher controls the location of the equipment, its operating parameters, and they can also call the operator by mobile phone. The introduction of the automated system for managing the process was preceded by the technological positioning and communication equipment. We have more than 300 kilometers of fiber optics underground. We have many Wi-Fi hotspots. We have 186 machines with positioning equipment on them. We have 100 staff trained. We needed new software hardware suites for the automated production metering, and we did it with the use of the latest technologies like machine vision, analytical data processing, and statistical processing of digital arrays. So we have digital system for managing the production process and integrated planning process and the plant performance control process. We receive online data on the equipment and the current progress for the jobs, and this lets us perform our estimates better, which makes the program implementation better. The management now can quickly respond to the discrepancies in the production process, and they can be more effective in coordinating the operations of the equipment. Last October, the underground dispatch program received the Russian Mining Award. And within the last 2 years, our program has received 8 awards, some of them international. We are following the innovative development trend. And this includes the technological tools we use and safety, which is also our top priority. The first stage of the program included the introduction of some baseline tools, and now we are at a different level. Now we are further introducing the digital future for the company for remote equipment management, big data analytics, decision making based on artificial intelligence, and also the human-free query or mine. And now we are testing our autonomous technologies. Last year, the Skalisty mine had the first driverless underground truck. Analysts believe that by 2026, the production efficiency increment will be $400 billion, and 330,000 jobs in the mining industry will have to be reinvented. The labor will have to be more intellectual. So we understand that we need to transform the operational model and the digital. So we need digital transformation and also mental transformation. That's why today we are in close cooperation with our HR department, and we are part of the corporate educational projects to support our staff to develop their competences to make them more effective in the things they do. So this was the first stage of our program, and then the second stage came. Here you can see the 2.0 technological breakthrough program, which was launched in 2020. It has 11 sub-programs, 49 initiatives and projects. Just like for the first stage, for every program, we have some milestones and roadmaps to implement these business milestones. We have budgets, we have KPIs, and so on. In 2015, when this started, we had a lack of experience in this field. And we have even less experience for the new initiatives. Nevertheless, The experience of the first stage lets us believe that Breakthrough 2.0 will be as successful. We are going to use some proven approaches, and we will further transform business processes, and we will provide information support to them. And just like at the very beginning, we are focused on the comprehensive approach here for the business tasks and for the IT solutions. We are further focused on the professional development of the team and the future users of the system. We have continuously running training events talking about the latest technologies. We'll further use the brainstorms where the business, production, IT people come together for a few days to develop new processes. Our experience shows that this gives everyone a level field of understanding, but it also makes people engaged long before the technology is introduced. Another important thing is to make our underground mine staff safe. We have 2-kilometer deep mines in the Skalisty mine, and we'll have the autonomous work, so people will be far from the dangerous area and the human factor will be reduced, and we will increase the efficiency of production. The new autonomous processes will ask for new knowledge and competences. The staff will have to be adapted to the new conditions, and for this we have training courses for digital literacy. The digital autonomous mine will be the final milestone in our Technological Breakthrough 2.0 program. A few words about the IT and mining community recognition of the program. In conclusion, I'd like to show you a video of this program. It was also awarded the Best Innovations video in October last year at the Minex forum. Please show the video.
Норильский никель – неизменный лидер.
Norilsk Nickel is a long-lasting leader in the mining industry in Russia and the largest manufacturer of nickel, palladium, cobalt, platinum, and other metals. We cover 1/9 of the land. Our metals make the life better and serve the dreams of exploration. We are trying to make our production more safe and environmentally friendly. For this, we developed the Technological Breakthrough program. This program has been on since 2015, and it works to make production more effective. And we also want to synchronize our KPIs. The result of the transformation will be the high effective adaptive digital production system with improved business processes.
Базовых задач из областей связи и позиционирования, аналитики и отчетности.
We have the positioning system, communication system, analytics, reports, production management.
Хорошо, спасибо.
В каждом из этих направлений мы обеспечили все рудники системами радиосвязи.
We have given all the mines positioning and communication equipment for effective cooperation of technological areas and for better labor safety. The system is further developing, and it will support connectivity and data transfer in all the mining and undercutting areas.
Okay. So, Peter, do you hear me? Dear Peter, do you hear me? If you hear me, then it's okay. I just need to know whether you know how to share your screen with your presentation.
Yep, I should be fine.
1, 2, 3, the interpreter speaking. Peter, can you hear?
You say so. Well, I will believe you.
Yes, I can.
Okay, thank you.
Воздуха и вентиляция по требованию. Для обучения персонала мы планируем создать инновационную виртуальную реальность. Новые технологии навсегда изменят отрасль, исключая нахождение человека в опасных зонах и создавая новые производственные специальности. Серьезным шагом к построению безлюдного рудника будущего станет внедрение автономного самоходно-дизельного оборудования и автономная электровозная откатка. В дальнейшем потребует решения серьезные задачи из области аналитики. Для этого компания планирует создать полнофункциональную финансово-производственную модель с имитацией технологических процессов, которая позволит прогнозировать будущее. Для мониторинга технического состояния оборудования мы планируем внедрить специальную дистанционную систему. Перед нами стоит немало задач из области средств моделирования. Для их решения на производстве будут внедрены симуляции различных режимов технологического оборудования, автономные и дистанционные управления, СДО и карьерный техникум. Для улучшения сквозного оперативного управления производством внедряются автоматизированная система интегрированного производственного планирования. Она позволяет проводить многовариантное планирование на всех горизонтах, от стратегического до оперативного, с маржинальным выбором лучшего варианта и оптимизацией его в имитационных моделях. Горнодобывающая отрасль всегда сталкивается с рядом сложных производственных задач. Каждая трудность — это новый вызов, который помогает нам оставаться в числе первых. Программа «Технологический прорыв» — это уникальный сплав инновационных решений и профессионализма большой команды. Являясь неотъемлемой частью Норильского никеля, она прокладывает путь передовой компании 21 века от традиционного управления горно-металлургическим производством к высокоэффективному цифровому.
Что хотел бы сказать в заключение? В ходе реализации нашей программы приходится решать непростые задачи, в том числе и задачи, которые еще никто никогда не решал. Но в результате работы...
And unprecedented. But our team is very experienced, and it brings technological and operational advantage to our company. We improve the HSE, and we develop new competences for our staff at all their levels. Thank you for your attention.
Владимир Александрович, большое спасибо.
Thank you very much, Vladimir. Thank you for telling us what we all are supposed to be doing in terms of the universities, what we should teach our staff, and how to make them in big demand. Hopefully, Peter Ross-Macari can hear us now. He is head of School of Mechanical and Mining Engineering, the University of Queensland, which is in Brisbane. That's where we'll have the World Mining Congress. Peter, are you with us?
Yes, I'm here.
Please welcome.
Are you able to see my screen?
not yet.
Right. I've tried to share it. I'll try again.
Okay, so Peter, you have to press green button, which is demonstration of the screen. It is down below. And there you have to choose the opened, I don't know whether you have PDF file, PowerPoint file. You have to choose it, and then most probably I will see it. Okay, thank you very much.
To talk to is around precision. So I'm Ross Macquarie. I'm the head of the School of Mechanical and Mining Engineering at the University of Queensland. And I apologise for the technical difficulties that we faced leading into this. There's no question mining's important to Australia's economy. It accounts for around 35% of our export earnings and around about 12% of our GDP. We're the largest exporter of a number of resources: coal, iron ore, lead, diamond, rutile, zinc, zirconium, and the second largest producer of gold, uranium, among has many dimensions, and automation technology has the, if you like, has dimensions shown here. I'm going to speak to a particular aspect of this now, which has been the focus of a lot of the research that we've been doing at the University of Queensland over the last 5 or 6 years, and that is what we call mission planning, and the idea that we should, through automation, be able to bring a new level of precision to the activities by carefully planned technical actions that are executed methodically and with exactness, and which are robust, so that if things don't play out exactly as planned, we're able to accommodate for them. And this really is the main focus of much of the research and implementation work currently going on in Australia. Our view, of course, is that automation is not the prize. It's just the means for optimizing business processes, so bringing better process control, safer operation, and higher levels of information about what's happening, distilled into operational data that can support decision-making. But this theme of precision seems to pervade everything. And I like this quote from Bruno Walter, who's a German pianist and composer. He has said of playing the piano, by concentrating on precision, one arrives at technique. But by concentrating on technique, one does not arise at precision. And our efforts to achieve precision have been largely through the solution of large optimization problems using dynamic programming and Bellman's equations. I apologize for putting up some mathematics here. It's not something I'm going to speak to at any depth here, other than to give you a sense of the main strategies that we are using to address our problems. And they are that we look to search at any time, given the state of the environment, all possible decisions measured against a metric to find the future sequence of decisions that gives an optimal outcome against that measure. And Bellman's equation, which some of you may be familiar with, is the foundation for this. The problem, of course, is intractably large. There's a saying, there's more than 1 million ways to dig a hole, and there certainly is. And so we look to prune the search of future actions that we make using a range of constraints and heuristics, and we apply this over a receding horizon. So we look ahead for some time into the future and then apply the first decision that we think forms an optimal sequence and repeat the process over and over again. One of the foci for our work has been draglines. Draglines are a significant part of the Australian coal mining sector because they are the cheapest operation in moving or uncovering coal, moving dirt to uncover coal. And there's around about 50 draglines in Australia. They're all large machines and they're all critical to our coal sector. But the challenge of being able to operate a dragline is a little bit like playing three-dimensional chess, in the sense that the system builds benches and moves dirt in very complex ways, which often confound operators. They have detailed plans, but perhaps if we could automate these machines, we could find a benefit from doing so. Now, that benefit largely comes from moving dirt less distance. And so this diagram here, which is what we would call a range diagram, in 2D gives a sense of the idea. There is, shown by the dashed blue lines, pre-survey. There is the orange line representing the final survey. And you can see the magenta line there giving the if you like, the ideal minimum movement of dirt scenario in this cross section. And there's a gap between where what operators achieve and what's possible. Also shown is a yellow line, which is the outcome of computation to try and achieve the best or optimal fit of material to the spoil shell. Now, I'm showing this in 3D, but when it moves in 2D, but when it moves to 3 dimensions, it becomes more intractably complex. This little video will give a sense of an optimization sequence. The orange dots represent points at which we are computing the ideal location of the dig. You'll see the dragline is actioning a position, and it walks up to the bench and is taking material, and it is spoiling it in some sense into the spoil area. And this is an example of an optimal calculation. In order to compute this calculation, we are looking at future positions, potential positions and actions of this dragline, and trying to find among all of the alternatives those which uncover the coal in the fastest available time. And so what is the prize that this can bring? There's a 20% production improvement that can be realised through optimising tub positions and placing spoil, also through enhanced situation. The capability to fit material into the spoil area is absolutely imperative if, when we get to the end of a strip, the dragline still has more material than space available to use. Significant rehandle results at large costs. We know that driving the machines at the limits of its motion, that is swinging and hoisting as fast as possible, give us an up to 25% gain in productivity. We also realise that we will never achieve those unless we automate the machine. And this is some of our journey towards that. The work we've done to date, which has yielded a 10% productivity improvement, is illustrated by the figure on the right, or the photo on the right, which shows an operator using an operator assist tool, which we've developed to help them position and choose where they should dig from and where they should spoil to. And on the left, you can see a replay of the operator's actions. There's future sequences indicated by the dashes. There's a new walk-up sequence being planned there, and the dragline will walk up along those blue dots, taking material indicated by the coloured gradients, and spoiling also by coloured gradients. This is to give you a sense of where excavation sequencing sits. Our most recent trials of this technology have shown a healthy 10% productivity benefit by providing the operator with sound decision support. Not quite automation yet, but on the road towards that. But it is an illustration of the benefits of bringing additional precision to operations. Okay, so what about hydraulic excavators? Another focus we've had is in trying to argue the case for automation of excavators. And this is by no means a straightforward case. In Australia, until recently, we've seen very strong deployments of automated truck systems in the Pilbara and automated drill systems across Australia. And the business case for all of those systems has been the operator salary savings that result from removing operators from their machines. It is not quite so straightforward with hydraulic excavators or road shovels indeed, but we've demonstrated technically that it is feasible to automate them. We've been trying to understand what the productivity benefits of automation are. And again, we come back to this idea of optimal sequencing, which involves a triple consideration of where to dig, where to move, and when to move. And I'll just play a little bit of video here to give you a sense of what we're doing. So here is a Caterpillar 6060 machine that is operating in a gold mine in Western Australia. You can see there's a terrain imaging system on board that machine. The green and the blue dots represent points obtained from LiDAR measurements, and the terrain that you see is the reduction of those points into its representative terrain. And we've been using this system to study the loading of excavators and their sequencing. Just move forward a slide. This video shows an optimal sequencing action for that site. The aim here is to compute where the shovel should locate itself, what material it should take while it's in that location, and where it should move to next. And you can see that it is looking to do a typewriter type excavation of a block, and it's come to an area here where there is more material than expected. Some previous parts of the block were not excavated as the machine went through. Now you'll see it's trying to find a strategy to do this, and its cost metric is minimum time for excavation here, and coming through to take out this material. And it's interesting that at some point it says, well, it's too expensive to take any more. It would be cheaper for me to move over and begin the next block. And it does that quite shortly. And so just to remind you, what it's doing is considering all of its possible future options, or at least the set that we've decided, and playing those out. You'll see here it performed a quite interesting maneuver where it cut into the face in order to make space for the truck to move in to minimize its swing time during part of that excavation. So where are the benefits here? What we're looking at is a slide that shows the performance of the system. This was a trial we conducted over several months, and this is the average productivity it achieved in that time, around about 17 or 1.7 times 10 to the 3 cubic meters per hour. If we could remove delays associated with this, we could bring it up to around 2 times 10 to the 3 cubic meters per hour in productivity. Those delays are delays usually associated with trucks being available. If the operator were able to operate as fast as possible, we'd see it comes to about 2.2 times 10 to the 3 cubic meters per hour. The truck positioning was reasonably good at this site, and we found little opportunity for better productivity. This category here relates to the fill achieved by the bucket at each stage. And again, there's quite a big opportunity to gather more material by excavation and finally sequencing. That is optimally placing the excavator and choosing the right material to dig at the right time. I raise these just to point out that there's a significant benefit on the table. All of these categories on the horizontal axis represent losses. And if we were able, through automation, to remove each of these losses or reduce each of these losses, we would potentially see a doubling of the productivity of the machine overall. I'm going to end with a third example of work we're doing, and that exists around precision excavation, and in particular the gap that exists around real-time ore body knowledge for autonomous mining systems. And we've been working with a local Brisbane company called PlotLogic to explore the potential of hyperspectral imaging to determine grade boundaries and ideally mineralization at excavation faces. The technology that we've been using is quite standard, I think, for the age. We're using convolutional neural networks to perform the classification, making use of a large body of images that have been collected and evaluated by geologists for their mineralization as the basis for determining this. I'll show you a result from this system, and here is the mineralization determined by core samples, or at least the grade boundary that has been identified for gold mineralization is shown here in the blue. You can see here we've augmented our base library of samples with some specific samples from this paste. So we had a geologist go and rank each of the regions that is shown there, and our prediction based on the hyperspectral images that we've taken, run through the resulting neural network, give us a reasonably good map of that mineralization, and in particular the boundary between ore that is greater than 0.5 parts per million and ore that is less than 0.5 parts per million, this being the ore grade boundary. You can also see the predictions down the bottom from those sampled areas. I'll move through this fairly quickly, but I guess the main thrust and the message I'm trying to give is that in terms of productivity improvement, the focus on precision that we currently have is beneficial. Other work that we've done has been in the automation of bulldozers and in the automation of underground trucks. These are other active projects which I've chosen not to speak to today. But these two have a focus on precision in their operation. A lot of the benefit from precision comes from eliminating what we might call operator losses. So inefficiencies in decision-making that operators introduce. And we anticipate that over the next 5 to 7 years, we're going to see a significant benefit derived as the technology matures and we see increased uptake of it. Thank you, and I'll end my talk at this point.
Большое спасибо. Напомню, что университет Квинсленда занимает 5-е место среди всех университетов мира.
Thank you very much. The University of Queensland is ranked 5th in terms of mining globally, and it's proud of its applied mining research. Thank you. You know that this year is the year of science and technology in Russia. Now I'd like to give the floor to the head of the Perm Federal Science Center, who will share with us the way the National Subsoil Usage Center is operating in the city of Perm.
Слышно, да?
Colleagues, hello, can you hear me now?
Да, вас слышно, все хорошо, спасибо.
Yes, we can hear you. Thank you.
Спасибо. Я бы хотел, во-первых,
My name is Alexander Baryakh. I'd like to thank the organizers who, despite all these challenges, have managed to organize a very important conference for the Russian science and education. And I'd like to offer my condolences to all the colleagues regarding the losses we have sustained within the last months. Now let's talk about my speech. You know, when Aleftina Chernikova invited me to talk about this, I wasn't that much inspired because this is a challenging subject. The Perm Training and Research Center was established following the governmental decision. So we were a first mover, and within 18 months, we have had this process of kind of establishing the work. And I believe that here, this should be discussed. We should listen to your feedback. And that's why I'll focus on our approaches and the issues we have seen today. Well, all the new things are well-forgotten old things. When we established our center, we found out in our archives this interesting paper. In 1988, a training and research center called the Deposits of Urals was established. This was organized by the Mining College, the Perm Polytechnical, and the Perm Classical University. This was signed by the chair of the Ural Department of the Academy of Sciences, Gennady Mesets, and it was also signed by the Minister of Higher Education of the Russian Federation, Academician Obraztsov. The approach in the 1990s to establishing the Training and Research Center was different from the approach we are using today. Well, this was a kind of symbiosis of education and science. And now we added here business, and at the final stage, this project became kind of local projects, so the regional projects. This kind of determined the essence of this work. This means that the training and research centers were within the authority of the regional administrations. A few words about the Perm territory. Higher education. We have 11 universities. 3 of them have the status of the institutes of science and research. So this is the first Ural Classical University, the National Polytechnical University, and the Perm branch of the High School of Economics. Our academic science. Today it is in the Perm Federal Research Center of the Ural Department of the Russian Academy of Sciences. There we have 4 institutes which are part of the Ural Department of the Academy of Sciences, and then the Perm Research Institute of Agriculture joined, and it was part of Rossельхоз Academia. And there are also some departments, some humanities, and they are smaller compared to the institutes or colleges. As of today, the center has about 1,000 staff, I mean the total staff. The center is considered to be the first tier center. While subsoil usage. A few words about the economy of the Perm territory. The Perm territory is an industrial district. We are a donor district. Machine building, engineering is well developed there. This includes engine building. We have a lot of chemical facilities, defense facilities, cable facilities, and this includes fiber optic cables, photonic elements. And we also have a lot of subsoil operations. This includes solid state, Verticam's potassium field, where we have more than 40 million tons of potassium ore, and we also have oil facilities, about 16 million tons production. Okay, the impact of business on science. We saw that the Perm mining and oil industries, if well, they invest into science about 800 million rubles, and if we add other mining companies there, then this becomes about 1 billion. And all the other industries like machine building and so on, well, they have far smaller investments into science. So the rational subsoil use was the beginning of this approach. Some internal background for this. Historically, the Academy of Sciences was related to our universities. I would say that 95% of the staff of the Perm Federal Research Center are graduates of the Perm universities, primarily the polytechnical and classical universities. We have departments, academic departments in the academic institutes. We have departments of the leading producing companies like Lukoil and Uralkali. We also have the Cadmium Institute, and this focuses on supporting the departments which are part of the training process for subsoil use. So, my alma mater department is the development of minerals, and there 90% of faculty, and we have about 50 people with the department. 90% of them are from the mining college or the Ural department. Why so many? They have 2/3 of the FTE, so we stimulate teaching, and I would say that the impact into education is very big. Within 15 years, the department had about 14 graduates, and we also had PhDs and doctors in mining. Okay, now let's talk about the PERM Training and Research Center. It's designed to support the priorities of the PERM territory in subsoil use by bringing together science, education, engineering, and production. The goal is to support technological breakthroughs in subsoil use, transformation of the economy, and better recognition and higher attractiveness. That's what I'd like to highlight, because one of the tasks set by the ministry and the administration of the region was to reduce the outflow of the young from the region. And the outflow primarily goes to Moscow and St. Petersburg. Here you can see the tasks: international cooperation, personalized training environment, new cooperation means for science and business, upgrading R&D infrastructure, and also retention of skilled and professional workers. So the members of the center, the PERM Federal Research Center, and 2 universities, the Polytechnical and the Classical University. So these are the core members. And this is an open environment. And now we have agreements with the Russian People's Friendship University and with some academic establishments. So despite our regional features, this environment can be further expanded. Well, collaboration is expanding. Subsoil use, some distinctive features in the PERM territory. In the 1990s, well, you know that many industrial universities collapsed. But in PERM, engineering stayed. This is primarily the PERM branch of Lukoil engineering. We also had, so this is a big company. We have more than 800 people working there. And we also have Uralkali subsidiaries there doing engineering for the biggest mining company in Peru. I mean, if we talk about hard minerals. The target model, the challenges, well, they are the same for all the mining areas. Tougher conditions for fields, more anthropogenic load on the environment. So I believe you all know the accidents we had in Berezhniki, looking for new opportunities for economic growth using resources. We also have a model to attain the global level. Partnership with leading R&D centers at national scientific and technological expertise for projects, and also an R&D environment supporting innovative development. Here we mean a continuous system when the students move forward in terms of the academic universities. They go to science, and they also go to production through the departments of the mining companies. The key areas. We didn't want to be limited by mining or production. We decided that we should also add here the business in terms of supporting subsoil use. The energy industry, automation and robotization, that's IT. And also the companies developing new materials and chemical facilities. So this is for beneficiation or processing. And this is also an important part here. Solid state minerals.
Создание и отработка технологий роботизированной добычи.
We developed and tested technologies for robotized mining. This has been discussed today. In this field, we have some achievements. Now we are testing the navigation system for the underground equipment. We are also developing geomechanical models for deep and safe mining. So this is one of the fields to protect the mines from gas and water breakthroughs. And one more thing is developing smart monitoring, since the facilities are in the urbanized areas, and the negative impact of mining, which has taken place for many years, is obvious there. Here you can see our partner businesses, not only from the Perm territory. We also have Belarus Kali with us, in together for quite a long time. We also have Nornickel with us. They recently tested a system for air conditioning in the deepest mine, the Taimyr mine. Hydrocarbons.
побыстрее пройти эти вещи, но на каких-то моментах остановлюсь. Значит, естественно, это цифровизация.
Naturally, utilization for production is important. And we also focus on tight reserves.
Химические технологии. Значит, большое направление связано с малотоннажным.
Chemical technology. We have a lot of technologies related to small batch chemistry. We are trying to replace foreign components for processing of minerals.
Энергомашиностроение. Здесь Пермский край – это газокомпрессорные станции.
We also build gas compressor stations. We have small gas turbines.
Это, по сути дела, полезная утилизация попутного газа.
And we, this way, use the associate gas produced with liquid hydrocarbons in the Perm territory.
Интересов компании «Лукойл».
And we do it for Lukoil.
Новые материалы.
New materials.
Очень широкие.
This is a really broad cluster.
Композиты.
This includes
Один
composites,
это, вообще говоря, той оборонной промышленности, которая трансформировалась в последние годы для
some elements of the defense industry, which has been used for civil applications, and also smart materials related to photonics,
это развитие систем
development of monitoring systems,
систем мониторинга и так далее. Ну и, конечно, очень важный элемент – это экологические вопросы и безопасность территории.
HEC.
Ну, конечно, я с определенным
This is important.
скептицизмом отношусь к словам природоподобные технологии, но тем не менее снижение воздействия горных
We
работ,
want to reduce the impact of mining and oil production.
безопасность
We want to support
территорий
safety
это те элементы,
in the territories.
которые необходимы
So these are the things we need.
недропользования. Ну, в частности, это применение и
And
биотехнологий
here we use biotechnology.
для
We use various strains
ликвидации разливов, которые
to
все-таки имеют
dispose of spills which still take place,
аварийных ситуаций. Что-то
especially
стал двигать, да?
in accidents.
Кадровый потенциал. Ну, вот
The HR potential.
мы попробовали выстроить такую линеечку, как бы как от науки, вообще-то говоря, науки по большому счету фундаментальной,
Research. How to move from basic research to the industrial partners or business partners. So we believe that industrial technological companies play a huge role here. So this is the transformation. 600, 700 researchers. At the engineering stage, we have thousands of engineers. And then we go to the industrial partners, business partners in the Perm territory. So you can see that this goes to 100,000 people. Well, this system has worked for some time, and it supports the orders we receive. Infrastructure.
Ну, достаточно она у нас оптимизированная, потому что
It's quite optimized. The Polytechnical University and some academic universities are on one territory. We are going to invite business partners to build the Center for Core Research and Storage. This is Lukoil, also Engineering and Science Testing Range, and the Center of Applied Science. If we manage, by the way, we have the dorms here, and we can also arrange their school program related to series.
Проведение исследовательских работ и образовательная программа.
Research and training. New technology. We develop science potential, we have applied research. This way we transform fundamental research into applied research. And we also do research for some business partners. Training, development of the engineering lift, meaning you go step by step from your student bench, then to the labs in the universities, and then you go to the labs and workshops of factories. International accreditation and certification for the training programs, development of professional training programs, and also academic mobility for researchers. Infrastructure development, upgrading the material and technical foundations, tools and equipment. In 2020 alone, 360 million rubles were invested into this, and we managed to retool our facilities. The social and economic impact. Well, maybe this is more obscure to us. We have it in the program anyway. So we want to, we want to increase the income and to improve the budget payments. Well, I don't know how to do it, but I believe that we can invite the talented youth and make science more popular, at least. That's what we can do. Some performance highlights. These are some abstract KPIs. And I believe that they need to be adjusted.
$1,400,000,000 это то, что получено вот всеми тремя участниками.
$1,400,000,000 is the amount the three parties received through their out-of-budget activities, as we call them. Here you can see funding in 2020. Out-of-budget funding. This means contracts with business partners, the funds for training students, grants, and so on. 240 million came from the regional budgets, and 144 million rubles came from the federal budget to develop the center. So the picture is unipolar, as I would call it. The results of the National Training and Research Center. And we need to perform against all those KPIs. If you fail at least one KPI, then we have to send back the funds to the federal budget.
те показатели, которые установлены для...
And here you can see the KPIs for the PERM Training and Research Center.
Вот на пятилетнюю, на 5 лет.
And this is for 5 years.
Вот некоторые мне очень хотелось бы прокомментировать.
I'd like to comment on some of them.
Объем выполненных работ и услуг завершил
The services and work done resulted in an industrial product or technology, 3 billion. Well, this is not realistic. If we don't invite other anchor participants. The number of articles, 1,300. Well, 20 in Scopus and Web of Science. Well, 720. So we believe that this big number shouldn't be our focus for the 3 institutions. We should pay more attention to the quality, the number of articles which are published by the first and second quartile magazines. And another thing, the number of new high-tech workstations we need to create. Well, to do this, 1,000 workstations, so you understand that we need a lot of funding. Issues.
Это, конечно, система управления. Практически во всех
The
ноцах
management system. In all the training and research centers, the management system is in the administrations of the territories. In our case, this is an autonomous, non-commercial organization which provides, well, the way we see it, it should perform some operational activities. It should organize meetings with the business partners, and it shouldn't manage the training and research activities. Well, some of the KPIs are inadequate, as I've demonstrated. We all see in 2019, 2020, we saw a low level of funding from the federal budget. Item 4. Well, this is something which caused a lot of headache, and we haven't yet sorted it out. It looked like that. There are 3 participants, and they were supposed to split the funds. The PERM Federal Center was the receiver, and the grant was split, but not by the bidding process. It was kind of appointed. This was against law 220. Well, so it wasn't within law 223, so it was to be done under law 44. Well, say we have a bidding process and anyone can participate. And as a result, we had to hire 350 staff members of the Polytechnical and Classical University. Now let's talk about business. We have talked a lot about it at the Federation Council level, and we said that businesses should be also interested in implementing the center's projects, so they should have some preferences for this. We discussed it, but unfortunately, we haven't made any progress in this field. One more thing. Competition between the members of the center. We are in one region. We have some say turf for departments, and here we have some clashes. Well, this can be overcome, but it's still there. And one more important thing is the lack of external expertise of the project for implementation in the center. So we think that these projects should be subject to some external expertise, and only after that they should be implemented in the training and research center. Since we have an avalanche of projects from the anchor participants and from organizations which are in the PERM territory. Well, we are optimistic at the Urals, so we believe that we'll be happy. Thank you very much for your attention. Thank you, Alexander. As far as I understand, the message to everyone is that you're welcome with your proposals on collaboration with the PERM Training and Research Center. Indeed, we'll be glad to do it. So apart from digitalization, we are also talking about the environmental support, and we also need to protect nature. So now the floor goes to the head of program for the business environmental responsibility of the WWF, Alexey Knizhnikov. The floor is yours. Thank you, Alexander. Hello, friends. Let me welcome you on behalf of the WWF. The previous speaker talked about some environmental safety issues, and I'll be glad to say a few words about the initiatives and the processes we have in the WWF to make the industry more environmentally friendly.
Видно, да?
Can you see it now? Yes, please make it full screen. Sure.
Так, что-то на полный экран у меня не получается. Сейчас.
Попробуйте нажать комбинацию клавиш Alt F5. Да, и теперь мы видим в виде этого Все, вы в эфире.
Да. Так, извиняюсь, коллеги, за небольшой сбой. Итак,
Sorry for the technical issues. Well, how to make the mining industry more environment friendly? Our approaches. So this slide shows the scale of the problem to the environmentalists. So you can see that this area is big, and some of these blocks are in the sensible areas, and this is in very important biodiversity regions. So we, the WWF and Russia, for many years have tried to pursue a systematic program to reduce the impact of the mining industry. And the first thing we did was to jointly develop the list of recommendations and guidelines to the industry to minimize the impact. This was published in 2009, and since then we have even engaged even more with this, primarily in the Amur and Arctic regions. We've been becoming even more and more effective. Last year, unfortunately, we had a lot of accidents, and one of them was related to a mining company in Taimyr. We all saw the huge oil spill, and this is a Nornickel accident. This type of accident shows that the priorities of environmental security can be even higher in terms of the work of the industry and various organizations. Okay, what do? We have initiated an interesting and an innovative project. We launched our own methodology to assess the openness of environmental information in the mining and metals industry. The first one was for the oil and gas, and this is for the mining and metal company. So this information should be open, because if it is not open, we cannot talk about effective measures to reduce the impact. So the first step is to make the environmentally important information available. In Russia, we have some systematic issues here. In terms of legislation, we don't have any tough requirement to unveil the environmental information. So we have forms for statistics reports, the 2 TP forms, and they show the impact indicators, but they're not public documents. For many years, the environmental community has tried to somehow solve the problem. No progress yet. Last year, Duma discussed a bill on the environmental information. It's close to becoming law, but if we talk about information openness or availability, we have some gaps here. And projects like our rating, they make this openness better. Now, rating, now we have about 40 companies. Our rating has about 30 criteria, and we believe that it supports an objective comparison of various companies in the industry. And this rating stimulates the companies to be more open, and it also stimulates introduction of more progressive practices and policies. A few words about the basic principles of our rating. So we believe that with these approaches, we will support maximum objectivity of our rating, and on the other hand, we build a mechanism for trust and interaction with the businesses. The first thing we have provided. So all the methods And all the criteria are discussed openly with the parties concerned, primarily the businesses. The second thing, we are responsible for the criteria and for methodology. The calculations are performed by an independent rating agency, which is picked based on a bidding process. And the rating agency uses the information in the public space. So this way, we stimulate the companies to open the information, and on the other hand, we show how objective our process is. Everyone can use the criteria and use the public data on the companies to see whether the calculations are good. We also have a really important approach, and this is a chance for the companies to verify the preliminary calculations. Every company can receive a preliminary table or spreadsheet, and they have a few weeks to give us feedback if they find any mistakes or if some information wasn't found by the agency, for instance. And this improves the quality of calculations and credibility. This is an annual rating since 2017, and we can see every year that the annual dynamics give more analytical opportunities to our rating. It looks like that. At the end of the year, we publish special information bulletins with the results of the rating. There they have the baseline table with the rank, and this is not the only advantage. The important thing is that every year, bringing this array of data, we start seeing some industry-related trends. And this is a unique environmental crosscut of the mining industry. A few words about the criteria. This was based on the public discussions and the documents I started with. And so this comes from the environmentalists. And we used some international standards like IRMA. And we have three parts to our criteria. The environmental management quality, we have 7 criteria here. And this is the most difficult thing because it's on the numeric impact and waste and so on. We'll have 11 criteria in this second part, and the latest part is on the dialogue and openness of the business. And here we use 7 criteria. As I've said, the second part is the most difficult thing. Quantitative indicators. The companies don't like sharing this, but we can see year on year, and this is supported by the public monitoring through our rating. More and more companies are showing more indicators. So how do we compare this? Part 2. We get data from every company on the indicators like emissions of pollutants per sales, for instance. This way, for every type of mineral, we can have the industry average. And then, depending on the average, we give some scores to the company. So we have a 3-tier assessment level, say green, yellow, and blue, and red. So if the company doesn't have the indicator, then they have the worst score, the red score, or 0. Okay, let's talk about the results. For different types of minerals, for different companies, here we analyze ferrous metals, 6 companies in the rating. We built some diagrams, and we can see that for some of them, the gap is big. And here we have some more effect from the rating, because if the gap is very big in an industry in terms of unit indicators, this might mean that the reliability of this data should be tested. Maybe there are some methodological issues here. Well, anyway, the closer these numbers are to the average industry, then the more reliability we have for these reports. Okay, emissions impact, and we also have some public tasks here. We also assess accidents and emergencies, and we understand that this happens to all the industries. We understand that the public can have issues with some industries which are not very good for the environment. Sometimes it causes conflicts, sometimes there are accidents. We can say honestly that businesses don't really like talking about issues like accidents or conflicts with the local communities. We believe that making these situations open, we can help solve the problem. So you should honestly and boldly learn the lessons and do it openly and publicly. And this will let you find, jointly with other players, good solutions and ways to avoid this in the future. So the no-risk nickel situation, it was extraordinary in many domains in terms of the scale of the accident. And I'd like to say that when this accident happened, the coverage of how they respond to this and how they coped with this within a few months. So the level of openness and transparency is very good. So the accident was really negative in terms of scale and impact. So we all know the colossal damage. But if we talk about openness in terms of response and interaction with stakeholders and ways to respond to this, so we believe that in this field, no-risk nickel was exemplary. Okay. We should focus on the biodiversity conservation. This is something which is in the core of WWF. We work in more than 100 countries, and this supports our global assessments, and we published the Living Planet report. And in 2020, we published this information on the half-the-century dynamics in terms of biodiversity. Unfortunately, this is quite depressing. We had to say that despite all the effort of many players in biodiversity, the trend is very negative. And we analyzed a lot of different species. So we had more than 400,000 species. And this sample says that the reduction in the number of species is up to 68% within half a century. So this means that we need to reinvent our approach to biodiversity conservation. For us, the environmentalists, this is a really important thing. So we need to develop the conservation areas, and we can see some renaissance here within the National Environment Project. So they're building new conservation areas, and they're supporting flagship species. So we have this part of the project. And in terms of business, we should be more focused on sustainable production. So this is the second pillar of our effort globally. And the third thing is at the level of consumption. The consumers should think more about the environmental impact of the products you buy. And we believe that this is another promising area. We know that many consumers, many industrial companies which buy raw materials, they pay more attention to the way these raw materials were obtained with the impact on the environment. Now, this is important in terms of making production and making mining friendly to the environment. So these are the negative numbers we are facing now, and we hope that the trend is going to be reversed in the next dozen years. Talk about the diversity. With our support and based on our initiative, Russia is now developing a new field in the business community. So the environmental impact from business is usually measured using 3 KPIs. So this are waste and emissions and pollution. So this is a kind of foundation to understand the environmental impact of businesses. And we say that there is a fourth component to it, how operations impact the living beings. So we have some specious indicators in terms of the impact. So it should be the fourth component to assess the environmental impact. And in this regard, we have seen some progress. And this was also promoted by the governmental order as of 2014 for the Arctic resources exploration and development. And we had also an order to the companies which planned to develop some offshore projects. So this included the corporate biodiversity programs. And there they had to add the indicator species for the impact. And this order was for the 5 companies. And it was very popular for the whole business community. And we supported this. And as a result, today, out of the 60 companies which are part of our rating oil and gas and mining companies, about half of them have the corporate biodiversity programs. And this is a lot of progress. In 2014, we had just a number of projects like that, primarily for the offshore oil and gas companies. Here you can see the list of the companies we have the corporate biodiversity programs in mining and in oil and gas. And we are confident that we'll have more and more companies like that year to year, because in Russia, this business approach is developing and the international processes are also supporting this. Every year, we are more and more focused on the quality of these programs, and we recently made the criteria more challenging. So we want to assess these programs. They shouldn't be just there. So we don't only look at the funds provided, but also the contents of the programs, the types of indicators the companies use to assess the environmental impact, the research programs, the availability of the results. Well, objectivity is really important. It should be there. It should be proven by the public assessment of the results the company demonstrates. And we use this SAP criteria to assess every corporate program. And as of 2020, the 12 mining companies who have these programs, so can be arranged into a rating in terms of the way they are promoting their programs. So when we can see a lot of red, this means that companies need to do a lot. We have some green spaces here. Now we have a lot of interest from the companies. They want to improve their progress. So we have another platform for interaction between science, environmentalists, and the business community. And we believe that the development of these companies will bring more green areas. There'll be fewer red areas, and the WWF will support the dialogue with the companies for this to happen. We have understanding of the importance of this and will further deal with it. That's it, colleagues. If you have any questions, I'm ready to take them. Thank you very much. So I believe that we will discuss these issues a little bit later. Okay, before the final speech, I'd like to read one more welcoming remark, which came later than we started. And this comes from the Minister of Science and Higher Education of the Russian Federation. Ladies and gentlemen, organizers, let me congratulate you on your international symposium, the Miners Week 2021. This event has been one of the longest ended events in mining. Now it's a platform for establishing productive contacts, for sharing latest developments and sharing latest experience in mining, earth science, and rational deposit use. Unfortunately, the ecological situation didn't let all the participants come together in one of the leading universities in Russia, but I hope that you'll be able to bring together remotely many people, maybe even more than in last years. You'll be able to use new forms of interaction between the scientists from different countries. And one of the important initiatives supported by the ministry last year was the consortium of deposits, which brings together all the leading Russian universities, training staff, and doing research for the minerals complex of Russia. So I'm confident that the Miners Week will further establish the dialogue between the consortium and universities in Russia and abroad. This year is the year of science and technology in Russia, and the events developing the important agenda in this field, which share the latest technologies and forge relationships in education, is really important. Hopefully, you'll be able to fruitfully discuss the rational usage of deposits and nature, and to be able to achieve technological breakthroughs in all the fields. I wish you all new networking opportunities, and may your plans come true. And please think about a good agenda for the next symposium, which is going to be held in a year, the 30th anniversary symposium. The Minister of Science and Higher Education, Mr. Falkov. Colleagues, and now, so we have worked a lot, and now I'll be brief in talking about the HR challenges in mining. And so we're talking about mining for the future. So this is the title of the plenary. Well, university trains the staff, which will be further employed by the companies. And by the way, the universities, so they are training and R&D centers, which develop the stuff and do research and R&D, and sometimes this is quite unique and only done here. This slide shows the new and promising professions determined by Headhunter and your job portals. And here you can see the professions which are obtained outside of universities. So this is done in professional schools for the workers. And here the question comes, universities, what is their space here? Okay, let's look at the Ministry of Labor of Yakutia and the information on the most demanded vacancies for the mining industry in 2020. So we can see that these are specific workers, specialists. So these people don't come from universities. So hence the question, what's the role of the university, especially in the mining field? So what is the position of the universities? So where should we kind of promote our work? So here you can see the number of companies and various colleges and universities in applied geology, mining, and oil and gas. So you can see the number is quite big. The number of establishments is big, and they are throughout the country. And so we have about 3,500 places for students and for engineers. So do we need so many of them? So this is a question to us. We need to understand whether there is any demand. The businesses want to understand whether we really train those who will be in demand in some time. We have some understanding. There is some discrepancy between the universities and colleges, and this difference is quite big. And the universities are, well, a big social training place, which makes people for the benefit of the society, to promote the whole humankind. But if we go down to our applied mining professions, then there is some demand here from those who come to us and those who graduate from us. And here we should understand that in this case, we should be thinking about the near future. The research globally performed, for instance, the World Bank, talks about this as a qualification pitfall. So people taking positions globally sometimes don't have enough qualifications, or sometimes they are overqualified. So they have very good qualifications, but they have to work for lower qualified professions and poorer paid professions in terms of their capacity. And in Russia, we also see this, and we should highlight that 1/3 of professions. So we have this pitfall, and we have an understanding that 1/3 of professions in 10 years will be extinct. So it will be reinvented, and new professions will come, especially those which are not yet even formulated. So we have some issues now. So and we understand that in 10 years, the situation will be completely different. One more thing to say is that in Russia, we also have quite a lot of situations like that. And in terms of economics of this, we should remember that the universities also receive some funds from the government and from the businesses, and this qualifications pitfall also undermines the GDP In universities and other places, the training approach is well established. So this is a comprehensive engineering training for 5 years, for instance, or 6 years. So this is quite a long time. So our experts graduate and they go to the mining companies, and they're not necessarily the final product. Maybe this is a semi-product which will be further honed and polished by the companies, helping them to understand the technologies and so on. So this is a semi-finished product. So the second thing is a comprehensive workers training. There is some demand for these specialties. So hence the questions, the boys and girls in the industrial areas, why should they go to the universities? They can get their specialty sooner, and they will be able to make more money than some engineers, and they are not in this qualification pitfall. If they want, they can further grow. We also have short-term programs for professional education for some experts which can work for companies, and there are short training courses for some specific competences. And we should understand that universities, they have some stages for training. So we start with understanding of what the companies do, and so they develop the business processes to the students so that they can pick their specialty, and the training curriculum can be personalized. Then we have placements, and this is about the companies which want specific experts, which want those who are not going to be semi-ready products, but rather a full-fledged expert the company needs. And the US website or program has forecasted and analyzed all the US environment. So this is the picture they can see, and here are the 30 best paid professions in the near future. Those who are going to make more than $100,000 a year. And in bold here, you can see those who are trained by our universities in mining and in energy support fields and technological equipment or environmental issues. So our training is important, but the business demand is something which we should keep in mind all the time. So it should be a kind of a beacon to everyone. So if you don't have state support, if we don't have funded places, who will kind of come to us? So on one hand, the mission of the university is clear for the 500 program. So the mission of the university is to give opportunities for full-fledged development of people, to inspire them for new challenges and to give them generate new knowledge and markets and businesses, and to give them navigation in the world of information. But we don't have any applied aspects here in terms of the answer to the business whom we are training. It's missing from here. And I believe that we should add these components here. And we should say that the university bears different functions. The social function, this is really important. As a university, so we say that we train the staff, and then they, after being trained, they live happily in the labor market. On the other hand, the university should and can be considered as an economic part of the market, meaning that we prepare a product we kind of sell, which is on demand or otherwise. And here we should understand some elements. Going back to the, I'd like to talk to Yuri Malyshev and Alexander Verzhansky. And so I believe that we should launch some new components to the dialogue. We should talk about training the staff demanded now and in the future, so we can have a round table, we can have a dialogue between the business and the university. We have said that the profession is being demonized, so people don't want to go to the mining industry, and parents often tell the kids not to do so. So we can see some gaps with the school training. Now, the school training is not focused on mathematics or physics. This is more difficult in terms of the national standard exam and so on. And this is bad for the ratings of the schools and so on. So we can see that the number of potential students is going down all the time. The level of personalization of the trajectory. What does the business need? So when should we start this individual trajectory so that we have the ready product and not a semi-ready product? Practical training for the junior years. So we understand the first and second years and the long 6-year programs. So the first 2 years is for the basic courses, and quite often the first-year students get too relaxed, or so they kind of get distracted from their specialty, and the training process becomes longer. We should determine how many engineers the universities should have. So do we have enough of graduates like that? Do we need smaller or higher numbers of them? Or maybe we should be more specific in terms of specialties. And is the business ready to pay for the training of the students if you don't have any budget funding for this? Or are they happy with the professional training? The importance of the state diploma. Okay, if a student comes from Australia with a bachelor's degree, they are happily employed. But if our student with our diploma from our universities, if they're provided, it's not necessarily needed for some of the functions. Another important thing, can the business shift to the 2-level system, for instance, to the bachelor's and master's degrees from the specialty degree? So these are the questions we should think about. And if we can have a dialogue between all the universities and the business partners, this can be really interesting. So if we can arrange it within a year, this will be great. If we can do it throughout the next minus week, so everyone is welcome. Thank you for your attention. Well, colleagues, I'd like to thank everyone for being with us in person and online. Thank you. So the first event of the week this year has been thus concluded. Everyone is welcome to the sessions and roundtables, and the nearest one will be in an hour. It's on digitalizing the construction of mining facilities. So you're welcome to take part in our agenda. Thank you, everyone. The plenary is thus over.